analysis is. So now say that you have a metal X and you expose that to a fast neutron, and say that neutron absorption occur with this unknown sample X. So what is X? The element is represented by the mass number and the atomic number. If neutron absorption occurs, it will then change to a new element. It will be, say, Y, it will be A plus 1, and the atomic number would be maintained, right? So if this new element is unstable, what does an unstable element do? They will actually decay, and there are many routes to decay. It could be alpha, beta, gamma, or it can release neutrino, neutron, and so on. There are many different routes to reach stability rate. So say that it decays with a gamma decay scheme or the gamma decay route, you'll get Y, A plus 1, Z, and it decays to another daughter, like say YZW, will be A plus 1, Z with the same mass and atomic number because gamma photon is uncharged. And if this is present together with the decay of Y, you can place this gamma photon onto your sodium iodide detector and use the calibration curve to identify the channel number, and then use the calibration curve to identify the energy and identify what nucleus Y is. So if this is, the daughter is still unstable, it will decay again. Say that it decay with the decay route of an emitting alpha. Say that alpha, A plus 1, Z, W will be A plus minus 3, Z, W, and this will be alpha. Alpha is 4, 2. And then it will keep on decay, so until it reaches to the stability rate. And now, say that you have identified what is an element Y, and you want to know the properties. So what are the properties of any radioactive element? It will be the half-life and the decay constant. So how do you get that? So half-life is basically, you can use the formula. You can use that, and you can get the initial activity from this result, or you can actually observe the decay over time. So that you take the unknown sample Y at 10 AM and you observe that for 2 minutes, and then say that the count is 100 count per second. And then at 10:30, you observed it for another 2 minutes, and you get another count. And then at 11, you observe it for another 2 minutes, and so on. So you go to up until count 50 to find the time T2 and T1. T2 minus T1 will be the half-life of your unknown sample Y. And what is decay constant? Half-life is equivalent to log 2 divided by decay constant. Now that you have the half-life, you can get the decay constant. So this is an example of how you can analyze an unknown sample with non-destructive method by bombarding fast neutron to the unknown sample. Alright, any questions? Alright, thank you.